You start now.
So hi everyone, my name is Rudi Verbeek. I work at Janssen, and I'm involved in the EMIF project. The aim of this talk is to briefly present what EMIF is about, what the project is actually doing or supposed to do, and then make the link to tranSMART and what we expect or maybe hope to get from people.
Yeah.
So can you advance to the next slide?
Yeah, sure.
So EMIF is an IMI project. I suppose most of you know what IMI is, the Innovative Medicines Initiative from the European Union. It's part of the Framework 7 program, very big program, lots of projects in there. As I mentioned there's more than 40 ongoing projects. EFIX is one of those. EMIF is another one, but there's many other examples. And it's a collaboration. It's a public-private collaboration. So European Commission funds $1 billion over a period of 5 years' time, but FPA, the pharmaceutical industry, has to match that either in cash or in kind, but has to come up with the same amount. So EMIF stands for the Electronic Medical Information Framework. The idea of EMIF is to build a platform. That's the basic idea. And to apply that platform to two called disease areas. One is metabolic. Well, some of these obese people develop diabetes. And what is the difference between obese people that stay healthy and obese people that develop diabetes? The data that we have within EMIF are basically two types of data. First of all, we have research cohorts, both for the metabolics vertical as well as for the Alzheimer's vertical. So these are cohorts, groups of patients that are being followed, for example, at a particular hospital or hospital center in time, and there's a lot of measurements being done on those subjects. People know, well, the treating physician knows these subjects pretty well, and they typically also publish on that particular cohort. The other type of data is what we typically have in, for example, hospital information systems. So these are data about particular, again, populations of patients that come to a particular hospital that get specific measurements to treat their disease, obviously, but that are not followed in the framework of a particular scientific study or scientific question. So the main difference between those two is that in the case of research cohorts, you typically have informed consent of the patient. In population-based studies, you don't, which makes it a lot more difficult in terms of anonymization, pseudonymization, patient confidentiality, and things like that. So that are typically things that we really need to pay special attention to. So these again are the data that we have. So we have, if you add all the different databases up, we should have access to about 15 million patients here. So that's quite a lot. Typical data sets are primary care data sets, so with your GP, hospital data, administrative data, and things like that. Biobanks are in that as well. If you count the number of patients in research cohorts, for example, we should have about 10 times the amount of subjects that ADNI currently has. So ADNI is the Alzheimer's Disease Neuroimaging Initiative in the United States, which is now, I think, in its second. So you had ADNI 1, ADNI 2, and now you have ADNI 2. So it's a project that's been going on for quite a number of years already, with hundreds of patients in there, lots of measurements, a really very, very rich data set. But we hope to get 10 times that amount of data. Now, these are obviously historical data. So where ADNI prospectively measures patients, so it's a longitudinal study, they follow patients, they have specific measurements that they do, measurement protocols in place that are the same over all the centers. In EMIF, we won't have that. So there will be, can you go to the next slide? There will be a lot of effort that we will need to put in EMIF into data harmonization, ontologies, making sure that we understand the data in the different cohorts in the population-based studies, and that we can match those, that we can do across-trial queries in a way that makes scientific sense. This is a map of where all those data come from, and as you can see, it's basically spread over all Europe. So EMIF is a big project with a lot of partners, a lot of logistics. So it's a tough project to handle from an administrative point of view. A lot of partners, as I said, 9 FPR members, there's 36 academic institutions involved, 2 patient organizations, and a couple of what we call subcontractors for specific, because of their specific technical knowledge usually. But coordinating this animal is really a challenge. Now, EMIF, as I already mentioned, the aim of EMIF is to build a platform. So that's one track. And to apply that to what we call, so that's the horizontal track, develop a framework evaluating and enhancing access to human health data. You all know that. The purpose then is to apply that framework to 2 research questions. One is Alzheimer's disease, and the other is metabolics. I'll talk a bit more about Alzheimer's disease because that's what I'm personally involved with as well, and that I know best. So in Alzheimer's disease, the treatments that we currently have, so the current state-of-the-art, scientific state-of-the-art for treatment of Alzheimer's disease is basically symptomatic. We cannot, by the time a patient is diagnosed with Alzheimer's disease, the disease is so far progressed that treatment is no longer really possible. So the holy grail in Alzheimer's disease is to try and identify people who are already in the disease process but do not show symptoms yet, do not show memory loss or maybe slight memory loss yet, or any of the other symptoms of Alzheimer's disease. So disorientation, shuffling, so walking difficulties, and things like that. So how can you identify patients before they actually show those symptoms? That's the real question in treating Alzheimer's disease. Yeah. This is the structure of EMIF. So we obviously have the IMI base on which we can build. Then there's the horizontal track for the platform with a number of work packages, for example, around data privacy, analytical tools, semantic integration, as I mentioned, that will be an important part in EMIF, information standards, data access management, so user authentication, user authorization. This is all obviously in the horizontal track, the platform track. And then there's 2 verticals, one for metabolics, one for Alzheimer's disease. The intention or the idea is to make this model sustainable even beyond the 5-year time frame of EMIF. So EMIF started in January. We're now in month 6. We run for 5 years. But the idea is not to stop after 5 years, but to build a sustainable model so that other disease areas, other scientific questions can make use of it. Yeah, I don't think it makes sense to go through all these work packages, but you see there's a couple of work packages around the a couple of work packages around metabolics, but the bulk of the work is actually in the platform. This is not correct. Can you exit for a second? En just terug naar die voorstellen. Exact. I had, this is actually a slide deck that's a lot bigger than the slide that I'm showing here. Just in interest of time, but the custom presentation doesn't seem to do it very well. Anyway, what's the roadmap for tranSMART in EMIF? So we're currently using tranSMART to load some cohort data for Alzheimer's disease into tranSMART. So the idea is that where normally IMI projects get a review somewhere halfway in the project. So for EMIF, that would be after 2.5 years because it's a 5-year project. The IMI has said, because it's such a complex project, lots of money involved, lots of partners involved, let's do a review after 1 year, which means early 2014 we'll get a review, which also means that we will need to solve at least the basic problems, technical problems, in a very short time frame, meaning that whatever software we have within the project, and tranSMART was something that J&J offered to EMIF. I see Peter in the audience as well. So the Erasmus MC in Rotterdam has often offered Jerboa, for example. So that's another platform that we have available within EMIF. So to use those platforms to get started as soon as possible and to already show some value for the review after 1 year. So for tranSMART, so we've opted for the cohort to upload a couple of cohort data into tranSMART. Peter is working on population-based data, for example, with Jerboa. So short-term deliverables is really, can we get cohort data into tranSMART? Can we do things like, can we make sure that privacy is protected for those patients? Can we do authentication, authorization? Can we do across-trial queries of those 4 cohorts? Which means that we need to come up with harmonized data, meaning harmonized measurements. How can we do that? Can we use the same names, same taxonomies for different cohorts? Or can we go even further and come up with some common global variables and then map each of the cohorts individually to those global variables? Series compliance is actually something that I haven't heard mentioning here before, but that is in EMIF is also one of the prerequisites from the AD, the Alzheimer researchers. So data curation, data privacy, and data access. But the idea is once we have that in place, we can get a couple of cohorts into tranSMART. So that's step 1. Now, next slide. Once we have that, so first step will be loading each of the cohorts individually. Next step will be to do a cross-trial queries. Very simple way to do that would be if you have the same measurements in different trials, well then you can just put them together. You can consider that to be a single cohort, basically. But the number of measurements that you can really consider to be the same is not that high. I mean, age is something that you can easily define. Gender is probably something that you can easily define as well. But what about cognitive measurements, like a mini mental state? Well, that's still doable. But some of the other memory assessments, for example, in Alzheimer's patients, they tend to be fairly ill-defined. So hospitals tend to use their own protocol with usually some common basis, but slight deviations. So is it still the same? To give you an example, there's something called the Bushka memory test. And in that test, the examiner reads a list of 12 words to the patient. The patient has to repeat as many words as he can. and that process is repeated 4 times. So the total score, if you get everything correct, perfect memory is 48. In some of the research cohorts in Alzheimer's, they use lists of 16 words, and they use 3 lists for a total score of 48 as well. But you can imagine that 4 times 12 is easier than 3 times 16. So they call it the Bushka memory test. Those two tests are called the same, but they're different tests. So how do you harmonize this? Is basically what we'll try to do here, where we say, well, let's call what these two tests are trying to measure is actually memory performance. So let's have something like memory performance assessment in our tranSMART taxonomy, and then try to map the 3 times 12 or the 3 times 16 or the 4 times 12 onto that same node that says memory performance assessment, where we have something like normal memory performance, slightly impaired memory performance, moderately impaired or heavily impaired. And then you can say, well, in my research cohort with my 3 times 16, I know that the normal range or the range for score range for people with normal memory is something between, I don't know, let's say 35 and 48. In my 4 times 12, normal memory performance could maybe mean 40 to 48. But then you can map to the same global variable that you could call memory performance assessment or something. So that's the idea in the second step. Yeah. Now, what does that look like in terms of architecture? So you have, well, the data sources on the left, obviously, could be population-based data sources, could be research cohorts. To expose those by having a local component that connects to the data sources, and that is somehow harmonized by using components. Now, you have the researchers on the right that are trying to access the data on the left. Now, the idea is not to put everything into a single data warehouse. The idea would be that the researchers here get access to what we call a catalog or fingerprints of the data sources. So they have a certain research question, and the question is, which of the data sources would be interesting, contain data that I could use for my particular research question, and then ask access to the owners of those data sources and see whether you can get access. Once you get access, the idea would be to put everything into what we call a private remote research environment. So you can't simply download data to your desktop. You can download it to a private environment where you can do your research and your analysis, either in tranSMART, in R, in SAS, in whatever tools you're used to. If it's standardized workflows, might as well be tranSMART. But my guess is that for research, the researchers will want to use their own tools, their own set of analysis, things that they're using. So there's a couple of requirements that follow from this. First of all, those people need to know how to use this environment. So they need, if this is tranSMART, they need to know how to use tranSMART. So that's something we need to develop. What is like training or videos that tell people how to do these things. Then we need those fingerprints. So they need a fingerprint browser. They need to be able to see which of the data sources could be interesting for their particular research question. Next step is then that the researcher contacts the data owners to say, well, I have this research question. Can I have access to your data to answer this question? Which means we need security, access control, authorization, all these things need to be in place as well. Next step, cohort owners give access, but they will obviously not give access to their hospital information system directly. So we need to take measures like privacy protection for the patients, data authorization, data authentication. Yeah. Then data goes through a common ontology or a data harmonization step. So we need that data harmonization to allow a cross-track query. Next step, what we actually would like to have is a federated architecture. So instead of putting everything into a single warehouse, that queries that start here actually go out to the individual data sources, and that anonymized data is then fed back into that research environment. So again, we need a private research environment, a rich analysis environment for data analysis, with flexible export tools, but again, within that private research environment, you're not allowed to download patient-level data to your desktop and then put that out on the internet. That's not with dedicated analysis workflows, because people would like to use their tools like R or SAS. Once they did their analysis, they would still like to get back to the state of the database as it was at the time they did their analysis. So we need some archiving for data traceability, analysis reproducibility functionality. What if a new data source comes on board? We would like to be able to have a flexible plugin architecture that we say, well, we have a new data source, let's just plug it in. So how do we do this? Well, we need ETL pipelines, for example, so that we can really easily do things like that. What if the data source contains new data types? Like, I don't know, next-gen sequencing, GWAS, whatever. If a new technology comes on board, can we plug that in easily as well? And one of the questions that has already come up is incremental data. So especially in population-based data where new patients visit the hospital every day, you would like to be able to capture the data that you measured today in an incremental lot of your source, of your data source, instead of having to throw your whole warehouse away and then reload it completely with the additional data that you measured today. And that's it. So if you can give me that tomorrow, I'd be very happy. Questions?
Yeah.
So among the things I was going to present this Wednesday is some of the reasons why we took some tasks away from ICB2 to get at data. It seems like a lot of the things you're going to want to do are places where ICB2 is almost done. Have you done your differential analysis of what's missing from Shrine and ICB2? What you want to get done?
No, this is, as I said, EMIF started 6 months ago. We're currently using tranSMART to get us to the region. Where so there's work package 14 is a specific architecture work package in EMIF that will have to draft the road towards where does EMIF want to be in 5 years' time, and how can we get there being where we are today.
So you've been straining your ontology support to what's in tranSMART today?
No.
So
No.
how are you extending that?
Well, currently we are not.
ICB2 offers modifiers. So if you want to say there's the same test but 2 versions of the test, you'd say the ontology holds a value for FJ modifier type 1, type 2. You still the same test. But it's not supported in tranSMART.
No, and it's not currently we're using tranSMART as